Good day, students. We are actually looking at the topic chemical kinetics, and in our last class we discussed on the various factors affecting the rate of reaction. Now, today's class we will be looking at order of reaction. Now, to start with, what is order of reaction? Now, the order of reaction can be defined as the sum of the power of the concentration of reactor which appear in the rate equation. So when we talk of order of reaction, we are actually talking of the sum of the powers of concentration of the reactor, as can be seen in the equation. Now let's consider this equation. If we have equation like this plus this giving us a product. Now if I want to find the rate of this reaction, the rate or the order of the reaction will now give me the concentration of A raised to the power of the mole, and then the concentration of B raised to the power of the mole too. So if I want to find the order of this reaction now, in respect to A, in respect to concentration of A, the order of reaction will be the small a. Then, in respect to the concentration of B, then the order of reaction will be equal to the small letter b. But there is what we also call the overall order of reaction. Now, the overall order of reaction will now give us A plus B. So when we talk of order of reaction, we simply mean the power of the concentration of the reactant. So if they ask you order of reaction in respect to a particular reactant, just know that is the power of the concentration of that reactant. But if they ask you for the overall order, then you add all the powers of the reactant together as shown here. Now we have different types of order of reaction. Now we have the first one to be first order. We have first order. We have second order. We have zero order. Then we have pseudo first order, and we also have pseudo second order. But as per O level, I'm going to treat just the first order, second order, and then the zero order. Now let's pick the first one, which is first order. Now, we can obtain first order reaction when the concentration of the reactant depends on the power of A. That is, the rate of reaction is dependent on the power of the concentration of A. Then, in such case, we have what we call first order. When the rate of reaction depends on the concentration of the reactant. Now, from this example, if I want to pick A, then when the rate of this reaction depends on the concentration of A, then I have my first order. Now, example of this first order can be seen in the composition of hydrogen iodide. If we have hydrogen iodide, Hi, the composition giving us H2 plus this. Now, to make, let me use the composition of NO2 plus O2. Okay, yes. Now this will be 2, and then this will be 4, this will be 2. Now look at this equation above. From this, if we look at it, this is a first order reaction because here our rate will be K into the concentration of Na2O5. So when you have something like this, what you have here is a first order reaction. That simply means that the rate of this reaction depends on the concentration of the reactant. Whenever you have the rate of reaction depending on the concentration of the reactant, what you have is first order reaction. Now, the graph to show this, you have something like your rate and then your concentration. So it's going to be a straight line graph. So this simply shows that the rate of the reaction is dependent on the concentration. So this concentration of the reactant. So this gives us first order reaction. Then we have the second order reaction. Second order reaction. This is obtained when the rate of reaction depends on the square root of the concentration of the reactant. When the rate of reaction depends on the concentration of the square root of the reactant. Now, if I have this, if I want to use this example I have here. Now, in respect to A, now I will have my rate to be concentration of A squared. Yes. So when you have something of this nature, it simply shows that the rate of this reaction depends on the square root, the square of the concentration of A. Then you have the second order. I think we can have this example in the decomposition of nitrogen oxide, where we have NO plus O2. So if you look at this, what we have here is a second order reaction, because in this my rate will give me K into NO2. So what I have here is second order reaction, and then the graph so from there the graph will be something of this pressure